Question 2, solve. You can see this recommendation that you verify that your answer is indeed a solution. So, the answer is something that you would get, right? Here is my answer. Your answer is only a solution if it makes the equation itself true. And in other words, this is a statement of equality. And if your answer makes both the left and the right hand side indeed equal to each other, then you have more than an answer, right? You've got the correct solution. So let's take a look at A. Um, Nothing terribly frightful here. I'm just going to use the distributive property to rewrite both the left and the right hand side. I'm going to write this as 3x plus 5 and then plus 2x minus 12. Notice that I'm pushing a factor of 2 into the parentheses, so it's hitting both the x and the negative 6. Um, so they have their factors that were distributed to them. On the other side, I've got the 3, and then I've got a minus 4x, and then a minus 4 again. We're pushing this factor of 4 into the parentheses. Now if I rewrite the left-hand side, I've got a 3 and a 2x, so that's for a total of 5x. And then I've got a 5 minus 12, which is negative 7. Over on the other side, 3 minus 4 looks like negative 1, and then minus 4x. And if I go ahead and, I guess I'll add 4x to each side. And when I do that, over on the left-hand side, I end up with 9x's minus 7. That equals negative 1. And I'm going to add 7 to each side. And when I do that, I have that 9x is just 6, right? Negative 1 and 7 is 6. And then to conclude, we'll divide both sides by 9. So x is 6/9. And you probably notice that there is a common factor there, right? Both of those have a factor of 3. I could rewrite this as 2 times 3 over 3 times 3. So you can see this giant 1 that's lurking in there. So probably I should write my answer. X is 2/3. Let's go to part B. Part B, I have this binomial that I have x plus 3 times 2x minus 1, and I think it's early enough in the year that I'm going to go ahead and use an area model to do that multiplication. So I am multiplying an x and a positive 3, and I'm also multiplying a 2x minus 1. And if I look at the values that go into each of these, in the upper left hand corner I have 2x squared. Whoops. Although it didn't look like it to. That's 2x squared. That's what I get when I multiply x times 2x. In the next box over, I've got a negative x. That's negative 1 times x. In the lower left, I have 2x times 3, which is 6 times x. And then in the lower right, I have 3 times negative 1, which is negative 3. So two of those are like terms, right? I can combine the 6 times x and the negative x for 5x. So let's go ahead and rewrite this. So again, all I'm doing is I'm changing the form, right? It was like the product of the length and width, and now I'm going to write it down as the sum of its parts. So I can write this as 2x squared plus 5x and then minus 3. And over on the other side, right, if you look at it, I've got a 2x squared and there is a plus 12. Okay, well, good news. I've got 2x squared on each side. So because of that, I'm going to happily subtract 2x squared from both the left-hand side and the right-hand side. And this equation simplifies greatly to 5x minus 3, and that equals 12. And I guess I could add 3 to each side. I'll undo the subtraction of 3. This becomes 5x would equal 13. I'm sorry, 15. I'm adding 3 to 12. And then if I divide by 5, x would have to equal 3. So it's a great exercise to take that and run it through both the left hand and right hand side and verify that it is a solution. And that's something that I think you should do, and you should do it with a calculator and practice doing it, because you want that to be just an automatic, quick process, so that you know you can get focused on the important thing, right? If you realize that it's not making the left and right hand side correct, the equal to each other, right? Then the real work begins of sitting down and figuring out where in here you may have perhaps made a mistake. Let's jump to part C, which looks fairly straightforward. I'm just going to distribute this. Well, it is a -3, so I need to make sure I push that -3 through to both of these terms. That would give me -6x, and then -3 times +1 would be -3, and that equals 12. I'm going to add 3 to each side, so that gives me -6 times x equals negative, actually +15. I'm adding 3. And then finally I'm going to divide by 6, so x equals 15 divided by a -6, and that can be simplified. Both of those are divisible by 3. I'm looking at 3 times 5 over, I'll write -2, whoops, I'll write -3 times 2. So the negative has to stay behind, but I definitely have a 3 over 3 that form a giant 1. So I get an answer of -5/2. X is -5/2. And then finally part D. Probably, I think I will use fraction busters, but not yet. I think I want to rewrite this and see if I can simplify it first before I try and multiply everything by an x. So let me just rewrite the left hand side. It's 2x plus 7. And then on the right, I've got 14 over x plus, I'm going to push this 2 through. I get plus 2x plus a 4 and then plus 1. And if I combine things on the right hand side, I've got 14 over x plus 2x plus the number 5. And over here I've got a 2x plus 7. Well, what's nice is I do see that both of these have a 2x, so I'm just going to subtract 2x from each side. And I am now looking at 7 equals 14 over x plus 5. I think at this point I'm going to choose to multiply everything by x. I'm going to spread this out a little bit. So I've got a 7 and then plus a 5. So I'm going to multiply everything times an x. All of my terms on the left and right hand side. The left hand side just has a single term. On the right hand side I've got 2 terms, so I'm pushing forward this factor of x to each of them. So x over 1 times x. What's nice about that is this particular term in the middle, right? It now has a giant 1 of x over x, which means, yay, it loses its fraction, right? So this simplifies to 7x equals 14 plus 5x. And I can take away 5 x's from each side. So I'm looking at 2x is 14, and I can divide both sides by 2. So x is 7. So there's something that feels terribly wrong about that, but I believe that's correct, right? X is 7. I, again, highly recommend that you take this value of x, plug it into the left and right hand side, and if I'm wrong, hey, come and talk to me, extra credit for you. But if I'm right, it turns out you just got a good opportunity to practice checking that 7 really is a solution here.